Hello, I'm David Burrow. I teach math at Bishop Garrigan High School in Algona, Iowa. Although it's definitely not Iowa you're looking at in the picture. That selfie was taken at the Delaware Water Gap on the border between Pennsylvania and New Jersey. Welcome to my students and to anyone else who happened across this. Good luck in studying for the ACT math test. We're now in part 4 and looking at the last 15 questions on a sample test. If you've missed the others, go back through the playlist and look at parts 1, 2, and 3. So question 46 says a container is 1/8 full of water. After 10 cups of water are added, the container is 3/4 full. What is the volume of the container in cups? And the possibilities are 13 1/3, 13 1/2, 15, 16, and 40. So the key to this is to write an equation. And it tells us that it's 1/8 full, and we're going to add 10 cups. That's where I'm getting 1/8 x plus 10. If I do that, it's going to be 3/4 full, 3/4 x. The x would be the amount a full container has. So to solve this, I've got to take 3/4 x minus 1/8 x. I did 3/4 minus 1/8 on my calculator and got 0.625. You could realize that that's going to be 3/8, but you don't have to. I just left it as 0.625. To find x, I take 10 divided by that, and it turns out the answer is 16. Number 47. Only 10th, 11th, and 12th grade students attend Washington High School. The ratio of 10th graders to the school's total student population is 86 to 255, and the ratio of 11th graders to the total population is 18 to 51. If one student is chosen at random from the entire school, which grade is the student most likely to be in? And it could be 10th, 11th, 12th, all grades are equal, or cannot be determined from the information. So what I'm doing to solve this is just figuring out what is the probability that everybody is in each of the different classes. So it tells us that 86 to 255 is the ratio of 10th graders to total students. So I just did 86 divided by 255, and I figured out that just under 34% of the school must be in 10th grade. I basically did the same kind of thing for 11th grade and found out that the percent there is just over 35%. Again, those are just dividing out what they give us as the ratios in the problem. Now I know that altogether we must have 100% of the students in some class. So what I did is I took 100%, or 1, and I subtracted off the probability that they're a sophomore, and I subtracted off the probability they're a junior. Since there's only 3 grades in this school, what's left has to be the probability of seniors, and that's about 31%. The question is, which class is most likely? Well, the highest of these is going to end up being 11th grade, and that's why the answer is B. Now, number 48 is a problem that a lot of people are just going to get scared away by because it's got square roots all over the place. We have 4 over the square root of 2 plus 2 over the square root of 3 equals what? And our possibilities are 4 square root of 3 plus 2 square root of 2 all over the square root of 5, 4 square root of 3 plus 2 square root of 2 all over the square root of 6. Then we've got 6 over square root of 2 plus square root of 3. 6 over the square root of 5, and finally 8 over the square root of 6. Now honestly, in the real world, when you're 3/4 of the way through the test and you see a question like this, if you're intimidated by a bunch of square roots, then just pick an answer, mark down that you might want to come back to it, and move on. To actually show you how the problem works, though, I'm going to show you a simpler problem. what I have here is a half plus a third. And the reason I chose that is that except for the stupid square roots, all that's going on in the problem we saw is adding fractions. And so we're going to look at a much simpler adding fractions problem. When you add fractions, what you do is you find a common denominator. You can always find that by just multiplying all the stuff on the bottom. So in this problem, we would multiply 2 times 3 and get 6. You find what goes on top by multiplying by the bottom of the other fraction. So I took 1 times 3 for the first one, 1 times 2 for the second one, and I figured out this problem simplifies down to 3/6 plus 2/6. When you add fractions, you add up the top, you leave the bottom alone, and that's why we've got 5/6 for this problem. The one from the test looks way harder, but it really just boils down to adding fractions as well. This time, the denominators, the bottoms of the fractions, are the square root of 2 and the square root of 3. So what I've got to do is multiply those together, and I'm going to get square root of 6 on the bottom. Now, already I know that this is either going to be G or K. The one from the test looks way harder, but it really just boils down to adding fractions as well. This time, the denominators, the bottoms of the fractions, are the square root of 2 and the square root of 3. So what I've got to do is multiply those together, and I'm going to get square root of 6 on the bottom. Now, already I know that this is either going to be G or K. On top, I multiply by the denominator of the other fraction, so 4 times the square root of 3 plus 2 times the square root of 2, and conveniently, that's exactly what the answer to G is, and that's why the answer has to be G. On 49, we have a picture of a circle and a line, and part of the interior of that is shaded. It says the shaded region in the graph below represents the solution set to which of the following systems of inequalities. So we're presented with a bunch of options here. The top 4 are pretty much the same except for greater than and less than. That's the only thing that's different about them. The bottom one, I will tell you, I know for a fact can't be right. And the reason I know it's not E is that what we have is a circle and a line. On E, you have the equations of 2 lines. One of them would end up being a horizontal line and one would be a vertical line, but that's not what's going on in this picture. It's got to be something that has both x squared and y squared for the circle, and then something that would reduce to y equals mx plus b for the line. So it's either A, B, C, or D, and what's going to matter is what's going to end up being greater and what's less. Now, something I do talk about in advanced algebra is when you're dealing with lines, greater than would mean above the line, less than would mean below the line. If it were greater than or equal, you'd draw a solid line instead of dots, but here what we have is above or below. For a circle, less than is going to be inside the circle, greater than is outside the circle. In this picture, what's shaded is inside the circle and below the line. That means I've got to have less than on both of them. Less than for inside the circle, less than for below the line. The only one that does that is A. Question 50 says you can find the volume of an irregularly shaped solid object by completely submerging it in water and calculating the volume of water the object displaces. You completely submerge a solid object in a rectangular tank that has a base 40 centimeters by 30 centimeters, and it's filled with water to a depth of 20 centimeters. The object sinks to the bottom and the water level goes up by 0.25 centimeters. What's the volume in cubic centimeters of the object? It could be 300, 240, 200, 150, or 75. So we know the base that this was submerged in measured 40 by 30. We also know that the height went up by 0.25. We can find volume by multiplying length times width times height. I did 0.25 times 40 times 30 and figured out it's got to be 300. So here we have, if the ratio of x to y is 5 to 2 and the ratio of y to z is 3 to 2, what is the ratio of x to z? Our choices are 3 to 1, 3 to 5, 5 to 3, 8 to 4, or 15 to 4. So they're basically asking us to find the ratio of the beginning to the end. And in order to do that, what I've got to do is make the middle number the same on both of those. So instead of 2 and 3, I've got to come up with the same thing in the middle. It's kind of like finding a common denominator. I figured out that 5 to 2 is the same as 15 to 6. And 3 to 2 is the same as 6 to 4. I'm turning the y into 6 both times, so that now what's left is x would be 15 and z is 4, and that's why our answer's got to be 15 to 4. Here we've got which of the following is the solution statement for the inequality shown below, and that inequality says -1 is less than 1 minus 3x, which is less than 10. And we got all kinds of different choices. We'll come back to those when we get to the answer. So what I want to do is solve an inequality that has 3 parts. And the way that you do that is you get the x by itself in the middle. And so I started off by subtracting 1 from all 3 parts of this inequality. Doing that, I got -6 is less than -3x, which is less than 9. To get x by itself, I've got to divide by -3. And I've also got to remember that when you divide inequalities by a negative, you got to switch the direction the thing points. And that's why I get 2 is greater than x, which is greater than -3. Now I've got one more thing shown on this slide, which is that in the original problems, the choices for the answers all had less than in them. And so what I did is I flipped this whole thing around and figured out that 2 is greater than x, which is greater than -3, would be the same thing as -3 is less than x, which is less than 2. And that's exactly what it says for choice H. Here we have formula for the surface area of a rectangular solid shown below is A equals 2LW plus 2LH plus 2WH, where L is length, W is width, and H is height. They're basically just saying you do 2 of every kind of side that would be there. It says by doubling each of the dimensions, L, W, and H, the surface area will be multiplied by what factor? Earlier, there was another problem that talked about something being doubled, and it asked what happened with the formula overall when you did that. And what I did on that problem is I literally doubled the variables that you put in and saw what happened to the answer. While I could do that here, there's actually an easier way to do this. And basically what you want to do is just memorize a little rule. Anytime you have similar figures, things that are the same shape but different sizes, whatever you change the length by, the area always ends up being changed by that factor squared. You can remember you measure area in square units, so it kind of makes sense that you'd square when you change the area. Sometimes questions like this will ask about volume. If it was volume, you cube the scale factor to get the answer. Here it talked about doubling the length of each side, so we're going to do 2 squared, and that tells us we got to multiply our area by 4. Number 54, a dog eats 7 cans of food in 3 days. At this rate, how many cans of food does the dog eat in 3 plus D days? There's a bunch of expressions here: 7/3 plus D, 7/3 plus D over 3, 7/3 plus 7 over 3D, 7 plus D over 3, and 7 plus 7/3 D. So I started out by setting up a proportion. I love solving things with proportions, and there's a lot of things you can do that with. Here I put 7 cans of dog food over 3 days, 7 over 3. We want to find out an amount of dog food, so I put X on top, and it tells us we want to know about 3 plus D days. And so that's what I put on the bottom. And what I do is I cross multiply. I get 7 times 3 plus D equals 3 times X. And now I'm going to end up dividing everything by 3. When you divide by 3, I've got to divide both parts by 3. And I end up with 7 plus 7/3 D. 7 plus 7D over 3. That's going to be K. Here we have Kelly asked 120 students about skiing. The results of the poll are shown in the table below. And we have how many people have either cross-country or downhill skied. And if they answered yes, how many have downhill skied and how many have cross-country skied. And we've got numbers in all of those different categories. Our question says, after completing the poll, Kelly wondered how many of the students polled had skied both cross-country and downhill. How many of the students indicated they had skied both cross-country and downhill? The choices this time are 73, 65, 47, 18, and 8. So the important thing here is we're looking at stuff that overlaps. Sometimes people will use what we call a Venn diagram to illustrate that, which is what I have here. The idea is I might have like cross-country skiing on the left, downhill skiing on the right, and we want the ones that are doing both, which would be that dark space in the middle. I can find what that overlap is by taking how many cross-country skied, how many downhill skied, add those up, and then subtract off the total that went either way, because it's going to add up to more than that total. What's left will be the overlap. So 28 plus 45 minus 65, when you work that out, you end up getting 8. So 5 more problems left. And this one says, the square below is divided into 5 rows of equal area. In the top row, the region labeled A has the same area as the one labeled B. In the middle row, the 3 regions have equal areas. And in the bottom row, the 4 regions have equal areas. What fraction of the square's area is labeled A? We could be 1/9, 3/9, 6/9, 13/12, or 13/36. So each of the stripes is a third of the square. And in those stripes, half of the top one is A, a third of the middle one is A, and a fourth of the bottom one is A. And that's why I put here a third times a half plus a third plus a fourth. I type that in with my calculator, remembering again that you can always just use divided by to enter fractions, and remembering that if you hit math, the first choice that pops up is change it to a fraction. And here, when I do change it to a fraction, I get 13/36. That's choice K. Question 57. The functions y equals sine x and y equals sine of x plus a plus b for constants a and b are graphed in the standard xy coordinate plane below, which we'll see on the next slide. It says the functions have the same maximum value. One of the following statements about a and b is true. Which statement is it? I'll point out first that in the picture, I highlighted one cycle of sine x because one of the things you should know from advanced algebra class is that the basic sine graph starts at the origin and it goes up, down, and back to the middle. The possible choices we have here is a is less than 0 and b equals 0. A is less than 0 and b is greater than 0. A equals 0 and b is greater than 0. A is greater than 0, b is less than 0. And finally, a is greater than 0 and b is greater than 0. So we want to figure out which of those is true. So what's really important in this problem is what do those a and b mean in a problem like this? And in this one, all that really matters is the b. And what a number at the end means is a vertical shift. It's how much you take a graph and push it up and down. Well, here, the vertical shift is 0 because the graph I have highlighted and the other graph both go up and down to the same points. It's pushed across, but it's not pushed up and down at all. And so the b in this problem does have to be 0. Conveniently, there is only one problem that has b equals 0, and the answer has to be a. So a very obvious question that I'm sure some people are thinking is, so what is that a that comes into the equation that we had there? A is part of what goes into what we call a horizontal shift. It's like how far you're pushing something left or right. Technically, you actually can't say for sure whether A is positive or negative in this problem, because you could either say that the second graph is a little bit to the left or a lot to the right of where the first one was. And because of that, it's okay to say A is less than 0, A is negative, but it would have actually also been okay if you said A is greater than 0 and B equals 0. The important part is B is equal to 0. So here we have which of the following number line graphs shows the solution to the inequality the absolute value of x plus 5 is less than -1. And you can see a variety of graphs that are shown here. They all somehow involve the numbers 4 and 6, and either we're looking at what's between those two numbers. We could be pointing in one direction or the other. We could be outside the two numbers, or choice K is empty set. Now, when I started making up this tutorial, I actually sort of screwed two things up. One of those is I started solving the equation, and it turns out you can't. And secondly, I forgot my own advice, which is that when you have a none of these choice, it's more likely that that's going to be the correct answer. And in fact, K is the correct answer on this problem. The reason you can't solve this problem is because absolute value can't be negative. It's impossible, and that's why the answer is the empty set. If you did try and solve this problem, you'd have x minus 5 is less than -1, and x minus 5 is greater than +1. Remember, when you have absolute value problems, you flip the sign and change the sign on the number when you're doing the second part. That ends up being x is less than 4, and at the same time, x is greater than 6. Well, you can't have any number that's both less than 4 and greater than 6 at the same time, and that's also why it's impossible. Question 59. As part of a probability experiment, Elliot is to answer 4 multiple choice questions. For each question, there are 3 possible answers, only one of which is correct. If Elliot randomly and independently answers each question, what is the probability that he will answer the 4 questions correctly? Our possibilities here are 27/81, 12/81, 41/81, 3/81, and 1/81. So obviously it's got something to do with 81. So the big thing here is he's got to answer the first and the second, and the third, and the fourth all correctly. And means times in probability. So I've got 1/3 times 1/3 times 1/3 times 1/3. That could also be thought of as 1/3 to the fourth power. When you do that, 1 times 1 times 1 times 1 is 1. And so we get 1 on top, 81 on the bottom. It's 1/81st, which is E. And finally, we make it to the very last problem. Number 60, the sides of an acute triangle measure 14, 18, and 20 centimeters respectively. Which of the following equations, when solved for theta, gives the measure of the smallest angle of the triangle? And then it says, note that for any triangle with side lengths A, B, and C, and opposite angles A, B, and C respectively, you have rules that you should know of as the law of sines and the law of cosines. And our choices, 3 of them have law of sines, 2 of them have law of cosines. It says sine theta over 14 equals 1/18th. Sine theta over 14 equals 1/20th. Sine theta over 20 equals 1/14th. 14 squared equals 18 squared plus 20 squared minus 2 times 18 times 20 cosine theta. And finally, 20 squared equals 14 squared plus 18 squared minus 2 times 14 times 18 cosine theta. So the first thing I'm going to point out is that if this was a law of sines problem, one of the angles would have had to have been 90, because all of those ones that come up in this problem would be the sine of 90. And it's an acute triangle, so it's not going to have a 90-degree angle. And that means right off, it's not F, it's not G, and it's not H. So we're down to the 2 that look like the law of cosines. And the important part of this is it says we want to find the measure of the smallest angle. And so we got to figure out which of these other 2 choices is going to be the one that'll give us the smallest angle. Now I drew a picture of what this would look like. It says it's an acute triangle, and it says that the sides that are involved here are 14, 18, and 20. So the shortest side's 14, the medium side's 18, and the big side is 20. When you write out the law of cosines, you always match up at the beginning and end the side and angle that are across from each other. So since we're trying to find the smallest angle, we got to match it up with the shortest side. And that's why 14 has to come first when we do this. And the only one that's left is going to be J, so 14 squared. The middle part you fill in with the other 2 sides, doesn't matter in which order. And then we have cosine theta at the end. So yeah, J is going to be the right answer. And that'll wrap up that ACT review with all 4 parts of it and 60 questions. Hopefully you did find some help in figuring out some strategies you can look for and how to work through those questions. Of course, you won't see exactly those questions on your test, but you will probably see some that are essentially asking the same thing but with different numbers and in a different way. So hopefully thinking through how these work will help you with the actual test when you take it.